It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start. You've built a perfectly normalized entity relationship diagram, but if you hand that picture directly to a developer right now, the resulting database will quickly fill up with invalid records, like negative item prices or missing primary keys. Getting your tables into third normal form handles the structural redundancy, but the design phase requires another step. This is the design sign-off phase. Before writing a single line of SQL, we have to translate our conceptual model into a strict, plain English specification that enforces our business rules. An ERD illustrates the general shape of your data. The specification acts as the concrete blueprint that actively protects the integrity of the system. To build that blueprint, we categorize our rules into three pillars. First is entity integrity. This dictates that every single table requires a stable, unique primary key to identify each row, ensuring we never lose track of a record. The second pillar is referential integrity. This rule demands that any foreign key must perfectly match an existing record in its parent table, or it must be deliberately set to null. You cannot have an order assigned to a customer ID that does not exist. The third pillar is domain integrity. This establishes the strict boundaries of acceptable values and data types for a specific attribute, like restricting an order status to only accept the text pending or complete. When these three sets of rules operate simultaneously at the database layer, the system automatically rejects invalid data the moment an insert or update is attempted. Classifying your constraints this way removes ambiguity for the developer tasked with actually building with tables. We document these rules using a data dictionary. This is a tabular breakdown that maps each entity's attributes to their specific data types, constraints, and business descriptions. A weak dictionary entry simply lists an attribute as a date. A rigorous entry, instead, specifies that the date must follow a 4-digit year format and physically cannot be set in the past. Let's test this. Pause the video and look at this empty row for a customer email attribute. What specific entity and domain constraints are required here? To enforce data quality, this field must be marked as unique to prevent duplicate accounts, not null to ensure we actually capture a value, and it needs a domain check ensuring the string contains an @ symbol. Your conceptual diagrams cannot capture this level of detail. The data dictionary holds the unambiguous business logic required for implementation. With the logical constraints mapped out, we can layer in conceptual physical considerations. By anticipating how users will query the system, we can mark frequently searched columns, like a last name or order ID, as candidates for database indexing. We also apply the principle of least privilege. We document exactly which user roles require read-only access, like a marketing team, and who is explicitly blocked from deleting records. For your Assessment 1 submission, traceability is mandatory. Your final written report must explicitly reference specific data dictionary entries and sections of your ERD to justify the design decisions you made. Professional database architecture requires this kind of evidence-based justification. It separates a completed specification from a rough draft. To complete your submission pack, you must assemble 5 artifacts: your final ERD, your relations in third normal form, a clear normalization log, the data dictionary, and your justification report. This checklist shows the final sign-off workflow. You move from a diagram to a specification, define the 3 integrity rules, identify your indexes and security needs, and make sure your written report references the evidence. Completing this package proves your design is sound. It is the final prerequisite before you boot up the server and write the first line of SQL.